Alright, so here we are with Unit 3.06, and we're going to be looking at some more properties with exponents and logs that will help us solve some more complex equations. So the first part is going to be kind of just some properties that we'll talk about that we can apply, and then we may do try and solve a couple of simple equations to prepare us for tomorrow. Alright, so we have a couple of properties here which are very commonly used in solving different equations, and we want to just kind of go through them. So the first says if you have log base a of x times y, that's the same thing as writing log base a of x plus log base a of y. And we want to talk about why that works. So think about log base a of x. What is that? Well, imagine what you're looking for is you're looking for the variable, we'll call it c, that you must raise a to so that it equals x, right? And so c in this case is the log base a of x, right? So this is c. Okay, and over here, the log base a of y is the variable, we'll call it d, that you must raise a to get y. So log base a of y is this thing d, whatever it may be. Okay? Now think about what x times y is. Okay? So what is x times y? Well, x is a to the c, and y is a to the, write an a to the d. And a to the c times a to the d, the exponent rule, tell me if I have the same base, I can add the exponents. So I have a to the c plus d is equal to x times y. But think about what this says, right? So here, the two things I'm looking for, what I'm looking for is the exponent, right? So using my log properties, what this is saying is that the log base a of x times y, well, what is that, right? Notice, this is asking, what is the variable that I must raise a to, what must I raise a to get x times y? Well, look here, what is that we must raise a to get x times y? It's c plus d. So this is equal to c plus d. And what is c? Well, c is exactly that value which I must raise a to get x. It is log base a of x. And what is d? It's log base a of y, because it's the value that I must raise a to get y. And so what we've shown is that if you have log base a, or log base anything, of x times y, it's the same as log base a of x plus log base a of y. Okay? And we're going to do the same thing with this other property. So this is our first property here. All right, and this other property says that if you have log base a of x divided by y, you can do something similar. You can take the log base a of x and subtract the log base a of y. And so we'll do the same thing again. We'll think about what these mean. So log base a of x is the variable, or not the variable, the value that I must raise a to. We'll call it c, so that I get x, right? And the log base a of y is the value which I must raise a to, we'll call it d, so that I must get y. And so remember what we're trying to do. We're trying to show that this side over here is the exact same thing as this side, just like we did here, right? We showed that this side here, which is c plus d, is actually log a of x times y, the left side. And so here, notice that log base a of x is that value c. It's the exponent of a. And log base a of y is d. It's what we're trying to raise a to so that we get y. And so now, instead of multiplying x times y, divide them. So x divided by y, well, that's a to the c divided by a to the d. And remember, the exponent rules of division tell us that the same base, when I divide, I just have to subtract the exponents, right? So I have a to the c minus d is equal to x over y. Okay? And if you are curious about why this works, just think about this. Think about taking 5 to the 4th and dividing it by 5 to the 3rd. right? You have 5 times 5 times 5 times 5, so 4 5s multiplied, and here you have 3 5s multiplied. Well, a 5 on the top and the 5 on the bottom, those simplify to 1, so you cancel out and you're left with just 1 5, or 5 to the 4 minus 3, which is 1. Okay, that's a little aside for you. Okay, so back to where we're at over here. The value which I must raise a to get x over y is c minus d. In other words, the log base a of x over y is c minus d, right? The value which I must raise a to get x over y is, well, what is that? C minus d. And so if I go back, and now we're a little cramped for space here, if I go back to my original situation, notice that the log base a of x is c, and the log base a of y is d. That's what we name them. And so by going through this algebra, we've shown that c minus d, or log base a of x minus log base a of y, is in fact the log base a of x over y. A lot there, but what we really want to focus on is that we can manipulate logarithms in a way that can sometimes be beneficial. So if you see situations like either side, you can change it into the other side. All right, so here we have an equation, natural log of x equals 6, and we want to solve. And notice that our variable x is the argument of the natural log. And so we need to find a way, how can we undo the natural log so that we have x alone and we can solve for it. And so think about what natural log of x means. Okay? The natural log of x is the number which I must raise e to in order to get x. So if I think about, I have e, there's some number I'm raising it to. Let's just call it c, and that's going to equal x. Okay? Well, this c here, that is the number which we must raise e to in order to get x. What's the natural log of x? That's the number which we must raise e to get x. In other words, the natural log of x is this number c. And so we can rewrite our situation here with that substitution. So e to the natural log of x is equal to x. Notice that all I did is say, what is c? Well, c is the number which I must raise e to in order to get x. Exactly what the natural log of x is. It's the number I must raise the base to e to get x. And so e to the ln of that x is in fact x. Okay? That should make pretty clear sense. But what it does is it's very powerful, because now notice that if I start with ln of x, the ln of some variable, and then I essentially raise that, I raise e to that power, like I have here, I end up with just that variable. And so let's actually apply it to this situation here. So I have natural log of x is equivalent to 6, and I want to isolate x. And so if I take each side and I raise e to the power of each side, so now I have e to the ln, that's well done, e to the ln of x, and on the other side I have e to the 6th power. Okay? Now on the left side, what is e to the ln of x? Well, remember we talked about it. If we take ln of some variable and we take e and raise it to that power, we're just left with whatever the variable is. Okay? So I'm left with x is equal to e to the 6th power. But e to the 6th power, it's pretty simple. That's just some number that I can compute. Okay? It's nothing too crazy, right? It's 2.718 to the 6th power, basically. That's a good approximation. And think about why this makes even more sense. Why does it make sense that x should be e to the 6th? Go back to our original equation. And imagine I start out with ln, x is e to the 6th, equals 6. What is this saying? Well, take a look here. The natural log of e to the 6th, what does that say? That says, what is the variable that I must raise e to so that I get e to the 6th? Well, that seems pretty easy, right? What do I raise e to so that I get e to the 6th? Well, that's got to be 6, right? No doubt about it. So obviously it would make sense that the natural log of e to the 6th is 6, right? Just like the log of 2, log base 2 of 2 to the 4th is 4, right? Why is that? Think about what this says. This says, what is the value? What do we have to raise 2 to get 2 to the 4th? Well, 2 to the 4th is 2 raised to the 4th power. So the exponent that we need to raise 2 to get 2 to the 4th is 4. Same idea here. But the powerful thing now is that anytime we have a variable inside of our natural log, we can get it out of there by taking e and raising it to the power of each side. And it's very powerful and will allow us to solve many, many equations. Right, here are a couple of problems for you to try. First, solve for x on parts 1 and 2, problems 1 and 2, so solve for x here. And then here is a half-life problem for you to try to refresh your memory. Good luck, and I will see you guys tomorrow.